Hey everybody, now we're doing 3.7 and it's about business applications. There's a lot here to well I'm going to go to um the textbook on this one. A lot of graphs and things like that. Okay, so here's our textbook. Oops, where'd it go? Here's our textbook, applications to business. So we're talking about consumer and producer supplies. So we have here a demand curve and a supply curve. This is the price, that's quantity. We have demand and supply. So let's see which is which. Well, the demand curve, that's the one that's decreasing. And the excuse me, the lowest prices is associated with higher quantities. So you see when the prices are low, the quantity is high, and the higher prices are associated with lower quantities demanded. The demand curves usually are often shown to be linear, meaning straight lines, but there's no reason they have to be. Now the supply curve is increasing because the lower prices that are associated with lower are associated with lower supply, and the higher prices are associated with the higher quantity supplied. It's just common sense. The point is that where the demand and supply curve crosses is called the equilibrium point, and we call that Q star and excuse me, Q star and P star. So that point right there. Now this blue area, as you can see, is the surplus. This is the so this is consumer surplus. This is producer surplus, meaning that a lot of consumer surplus because a lot of stuff was sold and producer surplus because the people didn't get to sell it, so they have it in the factories, in the warehouses, or wherever. Okay, so if the price is set at the equilibrium price, there's your price. So the quantity demanded equals the quantity supplied. Now, so assume that's the case. So think about folks who are represented in the left of the equilibrium point. Those consumers on the left would be willing to pay a higher price than they ended up having to pay. So the equilibrium price saved them money. On the other hand, the producers represented on the left would be willing to supply those goods for a lower price. They made more money than they expected to. Both of these groups ended up with extra cash in their pockets. That's pretty amazing. And people like that. So when you graph it, the amount of extra money that ended up in the consumer's pockets is the area between the demand curve and the horizontal line P. So that area that's in between the demand curve and the horizontal line P, this green line right here, that area is the extra money that's in the consumer's pockets. So this is the difference in price summed up over all consumers who spent less than they expected to, and that winds up being a definite integral because he's summing it up over all these consumers. So since the area under the horizontal line is rectangle, we can just simplify the area integral. So the integral from 0 to q star is d of q minus p star dq. And what's d of q? D of q is, oh, this is in the way. I gotta see. Okay, d of q is this is, oh, that's now it's always in the way. So that's d of q right there, and so we want the integral of d of q minus p star, and by the way, that's going to and that's going to represent this sort of this blue area, this blue, well, it's a triangle actually. So now that's going to be the integral of f of q dq minus the integral from 0 to q of p star dq. And that's going to be the integral from 0 to q star of d of q dq. It sounds funny, like to write it that way, minus p star q star. So the amount of extra money that ended up in the producer's pockets is the area between the supply curve and the horizontal line P. And that's the difference. This is the difference in price summed up over all the producers who received more than they expected to. Similar to the consumer surplus, this integral can be simplified. because the integral from 0 to q star of p star minus s of q dq, that's going to be the integral from 0 to q star of p star dq minus the integral from 0 to q star of s of q dq. So I'm breaking this up into two integrals. And that's p star q star minus the integral of s of q dq from 0 to q star, of course. So basically, if the demand function is p equals d of q, and the supply function is p equals s of q, and the equilibrium point is q star p star, then the consumer surplus, which is equal to the integral from 0 to q star of d of q dq minus p star q star. And the producer surplus is p of star q of star minus q, the integral of s of q dq, taken, of course, from 0 to q star. And the sum of the consumer surplus and the producer surplus, that's called the total gains from the trade. Because remember, we said everybody's a winner here. So what are the units? Well, the units are just a quantity of money. It's going to be price per item times quantity of items, and that just equals, amount of money. Meanwhile, this is all kind of theoretical. Let's do an example. So let's suppose that the demand for a product is given by P equals D of Q, which is equal to negative 0.8 Q plus 150, and the supply for the same product is given by P equals S of Q, which is 5.2 Q. So for both functions, Q is the quantity and P is the price in dollars. So we want to find three things. We want to find the equilibrium point, very important, very, very important point. Find the consumer surplus at the equilibrium point, and find the producer surplus at the equilibrium point. These are all super important to find. So let's see what we do. So for the equilibrium point, that's where the supply and the demand functions are equal. Well, we learned that one function is negative 0.8 Q plus 150. The other function is 0.5 Q. And we just got to take these two guys and set them equal. Where did I get this from? It came from right here. That's 5.2 Q, and that's the minus 0.8 Q plus 150. We set them equal because that's going to be where there's going to be two curves intersect. So the Q values are going to be equal. And if we solve for Q, we get Q is 25. Once we get Q is 25, all I got to do is take that Q and put it here and solve for P. So the price when Q is 25 is P equals 130. By the way, where do we get the 25? Where do we get the 130 from? Very simple. If I look at 5.2 Q and I substitute 25 for Q, so let's look at a calculator here. 5.2 times 25 to 5 equals 130. There you go. So that's fabulous. Okay, that's the equilibrium point, 25 comma 130. Now the consumer surplus, that's going to be the integral from 0 to 25, because 25, that's my Q star, of the negative 8Q plus 150 DQ minus P star times Q star. So this comes, if you work this out, this comes out to 250. And let's look at the next one. The producer surplus, that's going to be 130 times 25. Again, it's my P and Q, multiplied, minus the integral from 0 to 25 of 5.2 Q dq, and that is 1625. That's 1625. That's actually what's interesting here. The way we get that first integral is that the integral from 0 to 25 of negative 0.8 Q plus 150 dq, that's equal to, well, if I integrate this, I get negative 0.8 over 1 times Q squared over 2, that's how I'm writing it, plus 150 Q, that's the integral, evaluated between 0 and 25. Now I love zeros because there's nothing to do. So this whole thing is just going to zero out. But when I plug in 25, I get negative 0.4. Why 0.4? Because the 8 divided by 2 is 0.4. Times 625 plus 150 times 25, which I get from over here. I'm plugging in 25 for Q. That comes out to 3,500. But if you remember, it was that integral minus 130 times 25, and that comes out to 250. So that's where the first integral comes from. The second one was 130 times 25 minus the integral from 0 to 25 of 5.2 Q dq. And this is going to be 3250 when I multiply these guys out, minus, now this integral is going to be 5.2 times q squared over 2, so it's 2.6 times q squared, evaluated between 0 and 25, and I just plug in 25, and that becomes 3250 minus 2.6 times 625, because 25 squared is 625. And if you crunch that all out, you get 1625, which is exactly what the textbook has. So that's where the numbers came from. That's where those numbers came from. Okay, let's continue, and let's look at another example. Example 2. So the table below shows information about the demand and supply functions for a product. Now, for both functions, Q is the quantity and P is the price in dollars. Now, Q, so here we have Q and P. So these are the different numbers here. So which is which? In other words, which table represents demand and which table represents supply? I have two tables here. One thing I'm going to say is that on the top table, when Q gets bigger, P gets smaller. On the bottom table, when Q gets bigger, P also gets bigger. That's a bit of a hint. What's the equilibrium price and quantity based on this table? And question C, find the consumer and the producer surplus at the equilibrium price. So first things first, the first table shows decreasing price associated with increasing quantity, and that's the demand function. So obviously the other one is the supply function. Now, for both functions, let's look at B. For both functions, Q equals 400. That is associated with P equals 40. You see, look, see 440, 440. And that appears on both tables. Well, since the same P and Q appear on both tables, that must be the equilibrium. And see, it was easy as that. So the equilibrium, oops, where are you? So the equilibrium price is $40, and the equilibrium quantity is 400 units of whatever it is that you're producing here. So now we were lucky that it worked out very beautifully, but hey, that's sometimes it's good. Sometimes it pays to be lucky. Okay, you know what I want to do? I want to switch. Okay. Now the consumer surplus, that's going to be equal to, that's going to use the demand function, and that's going to come from the first table. So we're going to have to approximate the value of the integral using rectangles. There are 4 rectangles, and I choose left endpoints. So the consumer surplus is going to be integral from 0 to 400 of the demand dq minus 40 times 400. So this is going to be 70 times 100, 61 times 100, 53 times 100, plus 46 times 100, minus that 440 times 400, that gives me 7,000. So the consumer surplus is about 7,000. Now, I know what you're all thinking or wondering. Where did these numbers come from? 70, 100, 60, 100, so on and so forth. So let's take a look and see where these numbers came from. Now, I had to shrink this a little bit. So right here, I'm going from 70, 0 to 61, 100. So the width of the rectangle, so to speak, is 100. The height of the rectangle is 70. Because we're going with left endpoints. So the area of the rectangle is 70 times that gap of 100. The next rectangle is going to be 61 times the difference between 100 and 200, which is again 61 times 100. And then this 53 up here times 100, that's where that comes from. And then that 46. And that's the best I can do. I can't do an actual official, I can't do an antiderivative because they never gave me a function. They just gave me a table with values. And that's it. Now, and for the producer surplus, we're going to do something similar. We're going to use the bottom table. We're going to use the numbers from the bottom table, and we're going to get, drumroll please, 40 times 400 minus 14 times 100 plus 21 times 100 plus 28 times 100 plus 33 times 100. And that comes out to a grand total of $6,400, which is the producer's surplus. And again, with these numbers, 40, 14, 21, 28, you could see them. Let me go back up to the those are the numbers. I'm sorry, not the 40. The 40 is the equilibrium. Sorry about that. But the 14, 21, 28, 33 came from that bottom table. And that is how we do that. So now we're going to go to a different, you know what, I'm going to stop here and make a different video continuing from the interest. So I'm going to stop here and I will see you in the next video. Okay, bye everybody.